All right, welcome back. We are going to be talking about how to write numbers in scientific notation. So if you have a number that is greater than or equal to 10, so greater than or equal to 10, like this number right here, 15,237. So that is a number that is greater than 10. So whenever we have a number like this and we want to write it in scientific notation, we would be using a positive exponent. Okay, because we use positive exponents and powers of 10 to write really, really big numbers. And any number over 10 is going to be a big number. So let's figure out how we went from this standard notation to this scientific notation. So if you remember, when we were talking about writing in scientific notation, there was two parts, right? The first one is numbers written in scientific notation are written as two factors. The first, one factor is a number greater than or equal to 1 and less than 10. So basically, it can equal 1, but it has to be less than 10. And the second is the other factor is a power of 10. So let's talk about this. Is this number between 1 and 10 right now? It is not. It's 15,231. So we know that the decimal is here, right? And so we want to move this decimal place so we end up with a number that is between 1 and 10. So if I move this one place here, right? Now I have a number that's 1,523.7. So that's not between 1 and 10, so I need to move it again. Now I have a number that's 152.37, which is not between 1 and 10, so I need to move it again. Now I have a number is 15.237, which is not between 1 and 10. So I move it one more time, and I end up with a number between 1 and 10. 1.5237. This is a number that is equal to 1 and less than 10, or equal or greater to 1 and less than 10. So this is that first piece, right? Now, I know that the is a number between 1 and 10 times 10 and the powers of 10. Now, the powers of 10 have to do with the how many places we moved it, right? So we moved this decimal from here to here, and we did it 1, 2, 3, 4 times. So we're going to use a positive 4 because 10 to the 4th, that means making this number bigger to get it back to 15,237. We would need to multiply this by 10 4 times. So that's how we get it, this standard notation written in scientific notation. Okay, so that was discussing for numbers greater than or equal to 10. So 15,000 is greater than 10. Now let's talk about numbers. Let's talk about numbers that are less than 1, okay? So what would be a number that is less than 1? Well, this is a number that's less than 1, right? So how do we write this with scientific notation? Well, whenever you're writing really, really small numbers, you need to use a negative exponent. A negative exponent right here in this place represents writing really small numbers. So if we have this, right, remember to write that number in scientific notation, you have to, one factor has to be a number greater than or equal to 1 and less than 10. So right now, is this a number that is greater than 1? No, it's not. So what we need to do is we need to move this decimal place. And I'm going to move it this way because that's how I would get it to the number to be greater than 1. So here I move it one place. Is that number 0.0396 greater than 1? No. So I have to move it again. Is this number 0.396 greater than 1? No. So I have to move it again. And there we end up with 3.96. Now that is a number that is greater than or equal to 1 and less than 10. So that is going to be our first bit. Times 10. And then we know that this is a small number, so we're going to have that negative exponent. And how many places did we move it? We moved it 1, 2, 3. So that's why we have 3.96 times 10 to the negative third power. That is how we write this number, which is in standard notation, and we write it in scientific notation. Okay, so we talked about numbers so far that are greater than 10. Okay, we know that when we're dealing with numbers that are greater than 10, we need to have a positive exponent, like this number, 15,000. We have to have a positive exponent. It's a positive 4. And then when we're dealing with numbers less than 1, like 0.00396, we have to have a negative exponent to write that in scientific notation. But what about the numbers that are between 1 and 10? Okay, what do we do with those numbers that are between 1 and 10? Like, so for numbers that are greater than or equal to 1 and less than 10, like this number here, 5.36. How do we, that's a number that's greater than 1 and less than 10. How do we write that in scientific notation? Well, you use a zero exponent. And why is that? Because if we have 5.36, that is the number, right? So we can write it in scientific notation because this number is already between 1 and 10 times 10, but we don't want this number to get bigger and we don't want it to get smaller, right? So that's why we put this 0 here, because 10 to the 0 power is 1, and 1 times this number, just it stays the same. So this is how we write a number between that is greater than or equal to 1 and less than 10, how we write this in scientific notation right here. All right, so let's go ahead and get started on a few problems. Okay, just review. If you have a number greater than or equal to 10, use a positive exponent. If a number is less than 1, use a negative exponent here. And if you have a number that happens to be between 1 and 10, you want to write in scientific notation, then you just use that 0 in the exponent. All right, perfect. Let's go ahead and look at some problems. Okay, so example 2, translating standard notation to scientific notation. So we have this number here, 0.000003. All right, so we know that we're dealing with a really, really small number, so we're going to be using that negative exponent, right? Because negative exponents is how we write small numbers. Okay, first we need this number to be greater than 1. It's really, really small. So I'm going to have to move this over. 1, 2, 3, 4, 5. Now it's 0.3, but it has to be between 1 and 10. So I have to move it one more time. So I end up with 3 times 10 to, that's a really small number, so we're going to have that negative, and then we just count up the loopies. 1, 2, 3, 4, 5, 6, or the place values of 10. And that's how we write this number in standard notation in scientific notation. Okay, let's move on to the next. So here we're dealing with a really, really big number, right? So we know that we're going to use a positive exponent in for that power of 10. But first, we need a number that's between 1 and 10. This is way bigger than 10. So I'm going to have to move. Here's my decimal. I'm going to use these loopies. 1, 2, 3, 4, 5, 6. This is 46. I got to move it one more time, so it's 4.6, which is a number between 1 and 10, times 10 to the, and then we just, it's positive, right, because it's a really big number. 1, 2, 3, 4, 5, 6, 7. So 7 loopies, or 7 place values, right, because that's what happens. So 4.6 times 10 to the 7th, that's our answer. Okay, let's move on to C. Oh, you can see it. All right, again, we have a big or small number. Small number, so that means we're using that negative exponent. Okay, so I have to write this. This is smaller than 1, so I need to write it so it is bigger than 1, less than 10. So I'm going to move this over 1, 2, right there to 7.09 times 10. It's a small number, so it's going to be a negative, and then I count the loopies, 1, 2, 3. And there we have it. Perfect. Okay, let's go on to D, 810,000. Okay, first for scientific notation, we need a number that is between 1 and 10. So I'm going to have to, here's the decimal place. I'm going to have to move it over 1, 2, 3, 4, 5. So now I have 8.1 times 10. It's a big number, so it's going to be a positive exponent. Then I went 1, 2, 3, 4, 5 places. So that means it's going to be 8.1 times 10 to the 5th. Okay, now it is your turn, ladies and gentlemen. I want you to try E, F, G, H on your own. So where's my friend? Here's my friend, the pause dragon. Reminding you to pause your device. Go ahead and work out those 4 problems. When you get done, press play and we'll talk about them together. All right, see you in a bit. Okay, let's see how you did. So we have a super small number, right? So I know I'm going to be using that negative exponent. But first I need a number between 1 and 10. So I have to move this decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times to 2.74 times 10 to the, it's a small number, so we use that negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. And there's our answer. If you got that right, great job. Okay, let's move on to this one. Super big number, so we're going to be using a positive exponent. Here's my decimal. First, I need a number between 1 and 10, right? So that's going to be 1, 2, 3, 4, 5, 6, 8, right there. 1.37 times 10 to, that's a big number, so it's going to be positive. And then how many loopies was it? 1, 2, 3, 4, 5, 6, 7, 8, 9. To the 9th. If you got that one right, woohoo! Okay, on to G. Okay, still a big number. So it's going to be a positive exponent. And we need to write this. This number is not between 1 and 10. So here's the decimal. I need to move it over 1, 2, 3, 4. That ends up with 9.8856 times 10 to the, it's a big number, so it's going to be positive, and we moved it 1, 2, 3, 4 places times 10 to the 4th. Okay, if you got that one right, good, good, good. Okay, on to this one. This is a small number, right? So it's going to be that negative exponent. We need a number between 1 and 10, so I need to move this decimal over here once and twice. Now it's 5.05, which is a number between 1 and 10, so that's perfect, times 10. It's a small number, so it's going to be negative, and how many loopies? 1, 2. And that's it. So if you got all of these right, wonderful job. If not, go ahead and fix your work so it looks like mine. All right, we'll see you in a little bit.